Good day again, folks. So we're back, and today we are going to learn about the endogenic processes. Our last video was about exogenic processes, so let's take a recap.
That's it. We have learned the exogenic processes. Now, let's take a recap.
Exogenic processes include the processes of weathering, erosion, transportation, and deposition.
Weathering is the inside breaking down of rocks that transform it into sediments.
Erosion is the separation and removal of rocks and soil from its substrate due to gravity or transporting agents like wind, ice, and water.
Transport is the process by which sediments are moved by water, wind, or ice from its source to where they are deposited.
Mass wasting or mass movement is the downslope movement of rock, soil, and ice due to gravity.
Deposition is the process in which sediments settle out of the transporting medium.
Sedimentary environment refers to the area where sediments are deposited.
On the other hand, endogenic processes are driven by the forces and energy from within the earth. These processes are manifested through deformation, magma, volcanism, earthquake, and metamorphism. Deformation is caused by tensional stress, shear stress, and compressional stress. Magma is released through volcanoes, which are formed through volcanism. Metamorphism may be shock, boreal, contact, regional, hydrothermal, or cataclysmic. For further explanation, just stay tuned.
Rocks commonly found on the surface of the earth are in solid state. However, rocks also exist at certain locations deep inside earth. The molten rocks that are found beneath the earth's surface are called magma. They are less dense than the surrounding solid rock, therefore capable of rising to the surface. When magma emerges to the surface, it is called lava. Magma is usually composed of abundant elements including silicon, aluminum, iron, calcium, magnesium, potassium, sodium, hydrogen, and oxygen. Another property of magma is has a very high temperature. Magma also has ability to flow since it's a liquid. The degree of resistance to flow is called viscosity. The more viscous a substance is, the less fluid it becomes. The viscosity of magma depends on the silica content. Magmas with high silicas are more viscous than low silica magmas. Gas content and temperature also affect the viscosity of magma. Generally, gas content is higher when the temperature is higher, and this makes the magma less viscous. For instance, lava that just came out from the volcano has a very high temperature and flows readily. But as the temperature decreases, it becomes more viscous and eventually stops flowing. Magmas are formed under circumstances in special locations in the crust or in the upper mantle. They are formed when conditions are right to cause pre-existing solid rocks to melt. The common notion that the crust flows over a sea of a molten rock is wrong because the mantle is solid. Magma can be generated in several ways. Melting can occur when the temperature stays the same but the pressure decreases. This usually occurs in parts of the crust called rift valleys, mid-ocean ridges, and volcanic hotspots.
Another melting trigger is when volatiles or gaseous substances are added into the hot solid rocks in the process called flux melting. The water vapor or carbon dioxide will react with the rocks and weaken or break their bonds and cause them change from the solid to liquid states. This usually occurs in subduction zones. Magma can also be formed via a process called bit transfer melting. It is a melting of surrounding rocks caused by very hot magma that brings in additional heat. Extremely hot magma, 1,200 degrees from the upper mantle could raise and cause melting of the rocks in the lower crust, 500 degrees, which has a lower temperature. This occurs in Rift Valley, mid-ocean ridge, hotspots, and subduction zone. Rocks are composed of several different minerals which cause it to melt over a range of temperatures. A melting temperatures of the rocks, called eutectic temperature, is lower than the melting temperature of its constituent minerals when a rock begins to melt. Only center minerals are melted. This process is called partial melting. The rock will eventually be melted completely when the temperature is high enough. The magma formed by partial melting has a different composition than that original solid rock. If the magma is separated from the rock that has not undergone complete melting, the magma will consist of components that melted at the lower temperature, and the remaining solid rock will contain components with higher melting temperature. This process is called fractionation. During melting, the magma that is formed first tends to be richer in silica.
The magmas formed underneath Earth are less dense and is surrounded by the solid rocks. Another reason for their movement is when the pressure exerted by the surrounding rocks which squeezes the magma. Crystallization occurs when the magma and mineral grains start to form, and some magma moves all the way to the surface, but some solidifies underground. The most common igneous rocks are quartz or
Volcanoes are visible manifestations of the process of rock formation. It is the vent that serves as the conduit of lava. The mouth of the volcano wherein the lava were spewed out are called craters. The event wherein the lava are spewed out is called eruption. There are two types of eruption: the effusive eruption and explosive eruption. Effusive eruption is dominated by the flow of lava and formation of fountains and rivers. Explosive eruptions ejects ash and larger fragments of pyroclastic materials, forming ash clouds that eventually collapse and cover the slopes of the volcano. There are three types of volcanoes according to shapes. The first one is shield volcano, which has a very broad dome that covers a very wide area. The second one is the stratovolcano or composite volcanoes, which are composed of alternating layers of lava and pyroclastic materials. The third type is cinder cone, which consists of small cones formed by the spattering of lava. There are various types of materials formed during the volcanic eruption. Effusive eruptions form lava flow deposits. Lavas with smooth surface are called pahoho, while those with very rough surfaces are called aa. Certain eruptions would also produce pure volcanic glass called obsidian. Pumice is also made of volcanic gas but with very rough texture glass but with very frothy texture characterized by lots of open spaces formed caused by gas bubbles. The fragmental materials of various grain size produced by a volcano is called pyroclastic debris. Lapilli are pea to marble-sized fragments of lava. Volcanic ash are very fine particles composed glass shards, crystals, and fragments of existing rocks. The lithified volcanic ash is called tuff. The blobs of lava that are thrown into the air and develop as streamlined and smooth-shaped fragments are called bumps. Larger than streamlined chunks or pre-existing rocks are called blocks. The aggregate of pyroclastic debris that flows on the slope of a volcano is called pyroclastic flow deposit. A pyroclastic deposit that is dominantly composed of pumice is called ignimbrite. When the pyroclastic debris mixes with water, it forms a muddy-like slurry like lahar.
An earthquake is a vibration on the surface of the earth resulting from the sudden release of the energy. It could be a small shake that could sway hanging objects, or a very large movement that can destroy a building and can cause catastrophic damage. The breaking of the rocks beneath the earth. The breaking of the rocks beneath the surface as a result of tectonic forces produce earthquake. It is analogous of a breaking of a stick. When you hold a stick and bend it in the opposite side of it, you will apply stress or direct pressure, storing energy in it. When the force is suddenly removed, the stick will bounce back to its original form, releasing the stored energy. After continuous bending, the stick will suddenly back to its original form. After continuous bending, the stick will suddenly break and release energy in the form of vibration and sound. It returns to its original unbent form, but it's already shortened and divided into two. This concept is called the elastic rebound theory.
The place where rock ruptures and slip is a focus or hypocenter of an Earth. Energy radiates from the focus outward to the surface. The point at the surface directly above the focus is called Earth epicenter. The location of an Earth is defined not only by geographic location, latitude and longitude, but also by the tip of the focus. The energy released from the hypocenter of an Earth travels as seismic waves. There are different kinds of seismic waves, distinguished on where and how they move. Waves that travels within the interior of Earth are called body waves. Primary waves or P waves are body waves in which particle of materials move back and forth waves. Secondary waves are body waves where the particles of material move back and forth perpendicular to the direction of wave motion. They are also referred to as shear waves.
Waves that travel along the Earth's surface are called the surface wave, and it has the two kinds of surface waves. There are Rayleigh waves and love waves. The Rayleigh waves are the surface waves that cause for ground to ripple up and down, while the love waves are the surface waves that cause the ground to move back and forth in a snake-like movement. And we have here the seismic waves. They have different velocities. P waves travel the fastest and followed by S waves. The surface waves are slower. The instrument that detects and records the ground motion from an earthquake is called the seismograph. and the record is called seismogram. Seismograms consist of a heavy mass suspended on a spring and a rotating drum that records the motion.
The earthquake size is measured in two ways. The number that indicates the relative size of the energy released in an earthquake is called magnitude. It is determined from the maximum amplitude of ground motion recorded in seismogram, while intensity is the amount of damage brought about by an earthquake, usually denoted as Roman numeral. A large earthquake has higher intensity near its epicenter than in areas farther away. An earthquake has only one magnitude, but intensity varies in every locality, depending on the distance from the epicenter. It can be described as a combination of magnitude and intensity.
Tectonic force operating inside Earth causing rock to undergo deformation. It is a process in which rocks change in shape, size, location, tilt, or break due to squeezing, stretching, or shearing. It is the dominant process in the formation of mountain belts. In physics, a force applied per unit area is called stress. If the forces act uniformly from all directions, it forms a uniform stress, also referred to as pressure. The weight of overlying rocks exert pressure, referred to as confining stress. If the force is not equal from all directions, the stress form is called differential stress. There are three kinds of differential stress, namely tension, compression, and shear. Number 1. Tensional stress occurs when the dominant force is directed away from each other. It stretches the rocks, causing an elongation parallel to the direction of stress and shortening perpendicular to the direction of stress. Number 2. Compressional stress is formed when the dominant force is directed toward each other. It squeezes the rocks, causing shortening parallel to the direction of stress and elongation perpendicular to the stress direction. Number 3. Shear stress develops when the two dominant forces are directed toward each other but not along the same axis. It results as slippage and translation.
Rocks can be classified according to their behavior when under stress. Brittle materials have small regions of ductile behavior before fracture but could have a small or large region of elastic behavior. Ductile materials have large region of ductile behavior prior to the fracture but only small region of elastic behavior. Material behavior depends on factors such as temperature, confining pressure, and strain rate. Low temperature, low confining pressure, and high strain rate favor brittle behavior. Ductile behavior often occurs when there is high temperature, high confining pressure, and low strain rate. The mineral composition of rocks is another factor that influences deformation. Dry rocks often behave in ductile manner. Rocks found in the upper part of the crust also behave in ductile manner. Rocks found in the upper part of the crust behave in brittle manner.
It is because of low temperature and low pressure. At a depth of 50 kilometers below the surface, the rocks deform in a ductile manner due to increasing of temperature and pressure. This is called brittle ductile transition. Earthquakes occur only on the surface. Deformation mostly happens from within the earth, and the products are only revealed when the rocks are exposed due to erosion. The branch of geology concerned in the study of rock deformation is called structural geology.
Most of the structure resulting from deformation are planar structure, and their orientation can be described by position with respect to the horizontal plane. Strike is the compass direction of the line formed by intersection of an inclined plane and the horizontal plane. Dip is the angle between the inclined plane and the horizontal plane. The direction of the dip is perpendicular to the strike. Joints are natural cracks in the rock produced by the brittle deformations. The rocks on both sides of a joint do not slide past each other. Joints are formed due to tensional stress in brittle rocks. It can form when a rock cools and contracts, or when there is a decrease in pressure from overlying rocks as a result of erosion.
Like joints, faults are also planar structure resulting from brittle deformation, but there is sliding between the rocks. A fault where there is sliding in recent geologic times is considered an active fault. This fault can move again in the future and generate earthquake. Faults are classified based on the movement of the rocks with respect one to one another. In an inclined fault, the block of rocks on top of the fault is called hanging wall, while the block below is called footwall. When the hanging wall moves down with respect to the footwall, it forms a normal fault. If the hanging wall moves up, it forms a reverse fault. A reverse fault with the inclination below 35 degrees is called thirds fault. These faults are also classified as deep slip fault when the blocks slides past each other. The fault is called strict slip fault. There are two types of strict slip fault based on the relative movement of the block. When a block on the opposite side of fault moves toward the right, it's called right lateral strict slip fault. When the block opposite the fault moves to the left, it's referred as left lateral strict slip fault. If the movement of the blocks along the fault plane is diagonal, it classified as oblique slip fault.
Faults are produced by the deformation of ductile materials. Faults are contortions of rock layers forming wave-like curves. The hinge line or fold axis is the part of the fold where the curvature is greatest. And the limbs are the sides, fold axis of each folder layer. The folds can be described as based on the orientation away from of these parts. When the limbs of the folds incline away from the hinge, they form an arch-like shape referred to an anticline. When the limbs are inclined, toward the hinge, they form a trough-like shape called syncline. A monocline is a bend in a generally flat-lying rock layer. When the axial line is inclined and one limb is steeper than the other, the fold is described as overturned. Folds that are more complex develop depending on the degree of the compressional stress applying during deformation. During ductile deformation, the original shape and arrangement of the particles in a rock are also changed. Other minerals may recrystallize and reorient themselves. This alignment of deformed or reoriented grains is called tectonic foliation, which often occurs during metamorphism. Faults, folds, and tectonic foliation are formed in response to the different types of stress. Compressional stress forms reverse faults, folds, and foliated mineral grains. It also results in the thickening of crusts. Tensional stress results in the formation of normal faults and obliteration, as well as the thinning of crusts. Shear stress develops strike-slip faults.
The process by which Earth's surface moves from lower elevation to higher elevation is called uplift. Mountain belts are formed as a result of uplift and deformation of rocks in the Earth's lithosphere. The process of mountain building is called orogenesis. Continental lithosphere has lower density and floats over the higher density mantle rocks in a stenosphere. Continental collision results to mountain belt with thick continental crust. Mountain building shortens the crust horizontally and expands it vertically. This thickened crust is called crustal root. It gives the portion of continental lithosphere enough buoyancy to support the weight of the mountain range and allows it to float higher like an iceberg in the sea. When very old mountain belts are eroded, the continental lithosphere, including the crustal root, slowly rises to compensate for the removal of mass. This adjustment to maintain buoyancy is called isotasy.
Mountains are also formed when the formation is principally due to tensional stresses. This creates crystal thinning and develop reef valleys, where the dominant structure are normal faults. Examples of these regions are the African Rift Valley in eastern Africa and the Basin and Range Province of western United States. In this area, parallel normal faults are increased. Parallel normal faults incline in opposite direction form horse and graben structures. Horse are elevated landforms comprising the mountain and are bounded by normal faults that are inclined in opposite direction. Gravens are the valleys filled with sediments and bounded by a normal faults inclined toward each other. Are bounded by normal faults that are inclined in opposite direction. Gravens are the valley filled.
The process that occurs when a rock changes its form into a new one without undergoing melting or disintegration is called metamorphism. This implies that the change occurs in a solid state. The original rock or prolith undergoes mineralogical and textural changes due to modification of its physical or chemical environment. The shape, size, and arrangement of grains in the rock may change, and new minerals may grow. The transformation may take thousands of millions of years and would involve several processes.
Metamorphism occurs at temperature roughly between 200 degrees Celsius and 850 degrees Celsius, the temperature between diagenesis and melting. At high temperature, atoms vibrate rapidly, causing the bands to stretch and bend. If the bands break, atoms detach and move to form new bands with other atoms. This process leads to rearrangement of atoms within the mineral or to migration into other minerals. Crystallization and neocrystallization occur because of this process. Rocks formed below 320 degrees Celsius are low-grade metamorphic rocks, while rocks formed with 500 degrees Celsius are classified as high-grade metamorphic rocks. Minerals with relatively open crystal structure are stable near the Earth's surface. When these minerals are subjected to extreme pressure, the crystal structure becomes smaller and denser mineral forms. The transformation involves phase change and neocrystallization.
Temperature and pressure is changed with temperature and pressure is changed along them. The stability of certain mineral planar fabric. This apparent layering in the rock is a type of metamorphizing foliation. Preferred mineral orientation can develop through the process of pressure solution, plastic deformation, neocrystallization, and grain rotation.
We have the 5 kinds. Number 1 is recrystallization. Refers to the change in shape and size of minerals without changing their identity. Number 2 is phase change. It is the process that transforms a grain of one mineral into a grain of another mineral, having the same composition but different crystal structure. Number 3, neocrystallization, is the growth of the new minerals that differ from those in the protolith. Chemical reactions digest in the existing minerals to produce new minerals, sometimes with the aid of hydrothermal fluids. Number 4 is pressure solution. This refers to the dissolution of mineral grains when a rock is squeezed dominantly in one direction and at relatively low temperature and pressure and in the presence of water. Number 5 is plastic deformation. It occurs when some minerals become flattened or elongated without changing either the composition or crystal structure due to their plastic behavior when exposed to high temperature and pressure.
Faulting near the surface of Earth causes rock to break into angular fragments or to powder. At greater depth, rocks behave like plastic as they are sheared during faulting because of higher temperature. This leads to recrystallization of minerals in fault zones. This is called dynamic or metallastic metamorphism. It only involves shearing and does not require change in the temperature or pressure. The rock that is formed in this process is called melanite. It has foliation parallel to the fault.
In mid-ocean ridges, cold seawater penetrates the crust through the faults. It is heated by the rising magma, turning it into hydrothermal fluids. These fluids react with the excess basalt in the seafloor and produce new chlorite mineral. This process is an example of a hydrothermal metamorphism. Extraterrestrial objects like meteorite also cause changes in the rocks at the surface of the Earth. Vast amount of kinetic energy is transformed into heat during meteorite impact, enough to vaporize rock at the impact site. The extreme compression of the shock wave causes minerals to change its chemical structure. Quartz is transformed into coesite in this process. This is called shock metamorphism. Endogenic processes teaches us lessons about life, and one of them tells us that everybody keeps something within themselves, and we can force them to let it out or force them to share it with us unwillingly, because that may hurt them, and all we can do is wait and wait and wait for them, because the right time will come when it does.
Every individual has their own characteristics, appearance, and composition that we must love, respect, and accept all those to benefit from the life that has given freely to us.
Improvement takes time. The process of rock formation does not happen overnight. It's going through a long way before a rock gets formed.
People might drag us with them to places, but wherever those places are, we must not stop growing, adapt to the environment, and to be something.
Amen.
And that is the end of our lesson about the endogenic processes. But before we end this video, let's take a lesson recap.
The source of Earth's internal heat is attributed to leftover heat from its formation, as well as the radioactive of uranium, thorium, and potassium.
Magma can be generated through decompression melting, flux melting, and heat transfer melting.
The sequence of mineral crystallization in igneous rocks is called the Bowen's reaction series.
Volcanoes are the physical manifestation of the process of rock formation. It is a vent that serves as the conduit of lava or molten rock that reaches the surface of the earth.
There are 3 different types of volcano. According to their show,
Of the earth.
there are 3 types of volcano according to its shape: shield volcano, stratovolcano, and cinder cone. Its shape is a function of explosivity and extruded materials.
An earth is a vibration of the surface of Earth resulting from the sudden release of energy. The instrument that detects and records the ground motion from an earthquake is called seismograph, and the record is called seismogram.
The process that occurs when a rock changes its form into a new one without undergoing melting or disintegration is called metamorphism.
The different types of metamorphism include contact metamorphism, boreal metamorphism, dynamic or cataclysmic metamorphism, regional metamorphism, hydrothermal metamorphism, and shock metamorphism. And that is the end. Thank you for watching. We hope you learned from it.
Natawa kasi ako dun sa